Okay.
Start out treating it a little easier.
Yeah, I think I probably sort of working backwards on so first equation says cosine 4x is cosine 2x, huh? How is this possible? Well, we could get this as quadratic cosine 2x, right?
Yep.
How would you do that? Use the double angle identity, right? There's 3 for cosine. Which one would be useful here?
The cosine squared minus 1.
Yeah, 2 cosine squared 2x minus 1. So now it's quadratic in cosine 2x, right?
So we couldn't have just subtracted the cosine from both sides? The
No,
cosine
you can't.
2x?
Yep, I mean, that's what I'm going to do next,
But first, okay.
which you wouldn't hurt as a first step either. You'd get 0 on one side right away. But, you know, what you're your sub-goal is to get, you know, cosine of the same variable, of the same input, right? So you can say, I want to solve for cosine 2x. Now, my unknown is cosine 2x, and that's the only unknown, right? Here there are 2 different unknowns. Cosine 4x is unknown, cosine 2x is unknown. If I use the identity, I have only one unknown, cosine 2x. Which, okay, so let's write this then in descending powers. So that's quadratic in cosine 2x. Now what? Factor. Can I factor? Well, what's the discriminant here? B squared minus 4ac is the discriminant in general. In this case, that'll be 1 minus negative 8, which is 9. What does it mean that the discriminant is a perfect square? That it's going to factor nicely, right? So I, with confidence, start out by, well, the first factor's got to be 2 cosine x or cosine 2x, sorry, 2x. And then we need a 1 and a negative 1, and it's going to be plus 1 and minus 1, right? So either cosine 2x equals 1, or cosine 2x equals negative 1/2, right? And I would dial those up on the circle right away, see where I am. So 1 is here. So this implies that 2x is an even multiple of pi. Right? 0 or 2 pi or 4 pi or 6 pi, right? That's 2x. Now, of course, that means that x is going to be any multiple of pi. So negative 1/2 is over here on the x-axis, right? And that'll give me this angle, which is 2 pi over 3. Or this angle, which is negative 2 pi over 3. I tend to like to think of cosine as plus or minus, right? But you could also then go 4 pi over 3, like that, right? This is 4 pi over 3 station, right? And so this says that 2x is equal to plus or minus 2 pi over 3 plus any multiple of 2 pi. All right. And what does it say? Solve in the interval from 0 to 2 pi. So what are the solutions in the interval from 2 to pi, 0 to 2 pi? Well, x is going to be equal to k pi, which could be 0 or pi. Those are both in the interval from 0 to 2 pi, including 0 but not including 2 pi, right? Now how about these? Well, if I take the positive and k equals 0, oh, sorry, I need to solve for x first, right? So x is plus or minus pi over 3 plus k pi. I want positive angles, right? So I'm gonna say that's pi over 3,
That's
k is 0, sorry?
So you just divide it by 2.
Yeah, that's all, just divide each term on both sides by 2. Right, so that's from here, right? And this is from here. So I've got these values, and now I'm working on these values. So pi over 3, k equals 0, and we take a positive. If we take negative pi over 3 and add pi, that's like pi minus pi over 3 is 2 pi over 3. Are there any more? Well, if I take, so this is k equals 0, k equals 1. If I have pi over 3 plus pi, that's going to be 4 pi over 3. Is there another one I'm missing? So pi over 3 plus 0 is pi over 3. Negative pi over 3 plus pi is 2 pi over 3. Pi over 3 plus pi is 4 pi over 3. Negative pi over 3 plus 2 pi over 3? Yeah. That's going to be 5 pi over 3, right? Is there more? Well, notice that these are pretty much giving me all multiples of pi over 3. I got pi over 3, 2 pi over 3, 3 pi over 3 is pi, right? So I got 0, pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, and 6 pi over 3 is 2 pi, so that's outside my range, right? So yeah, I've got these 6 different places, evenly spaced around the unit circle. Pi over 3, 2 pi over 3, 3 pi over 3. Sorry, I did that wrong.
Yep.
This is pi over 3, 2 pi over 3, 2 pi over 3. 3 pi over 3 is pi, 4 pi over 3, 5 pi over 3, and that's it, right? So this 2, 3, 4, 5, and then 0 is also a solution, right? So there's 6 different places evenly spaced around the unit circle with central angle 60 degrees here, right? Another 60 degrees here, another 60 degrees here, and so on, going around. All right. How are we doing? Should we skip on to the end? Work our way backwards? No, that's the end. Okay. So, find all solutions. So it's more equations at the end, right? 2 sine 5 theta minus root 3. It's benchmark values, right? So what could be easier than that? How many solutions are there going to be to this? It's a good thing to know what to expect at the beginning, right? At 5 theta. 10 actually, right?
Oh.
Because if it was just theta, there'd be 2. The primary solution plus its supplement, right?
Oh, yeah.
And then for each of those 2, there's going to be 4 more for the multiples of 2 pi over 5. So let's do part B of that one. Cosine and cosine. So it's all just quadratic and cosine. What's the discriminant? 49 minus 24 is 25. Oh, the discriminant's a perfect square. So that means it factors, right? What if it didn't factor? Yeah, it's just annoying. You just have to work with radicals then, right? And art cosine and whatnot. But yeah, this one factors, so it's 3 cosine squared. Is it just theta? Just theta. What could be easier? Minus 7 cosine theta
Plus
plus 3.
Two.
Oh, 2 equals 0. And so, having computed the discriminant is a perfect square, I'm confident that I'll be able to factor, and I know this should be a 3 cosine theta and cosine theta to get 3 cosine squared theta. It's got to be 1 and 2 or 2 and 1 with both negative signs, right? So -1 and -2 does the trick, right? So either this factor is 0 or that factor is 0. One of these factors can't be 0. Which one?
The -2.
Yeah, the second one, right, because cosine is at most 1, right? And 1 minus 2 is not 0, right? So this cosine minus 2 will range between -3 and -1, huh? So it's never 0. So we just look at this one and say cosine theta could be 1/3, right? Which means theta could be plus or minus the angle whose cosine